Welcome back, everybody. Today we're going to be looking at how we can determine a proportional relationship from a table. So by the end of today, you'll be able to determine whether tables are proportional and to be able to find the constant of proportionality from that table. We'll talk about what that constant of proportionality is. You'll accomplish this by finding the unit rate of the relationship between y and x in the tables that we look at. So proportional relationships with tables. We're going to be given a table and we need to decide and determine if it represents a proportional relationship. To decide, we're going to write each of the ratios from the table, and we're going to write those ratios using a y over x. Okay, it's important that it is always y over x, and that will find the unit rate for us. If all of the unit rates are the same, then the table is said to be proportional, and there exists a constant of proportionality, which is the unit rate. Okay, we'll see how that goes. So here we have this table here, and we can take each of these points, and we're going to, let me move this real quick, move this up here, okay? And we're going to take each of these ratios and write them as y over x. Now, this is x, this is your x value, and this is your y value. So when we write these, we're going to write them as y over x. Let's take a look at this first one here. Okay, so y over x is going to be 10.5 gallons for 3 hours. Okay, let's take a look at our next one here. 21 gallons for every 6 hours. Our next data point here is 31.5 gallons per 9 hours. Again, notice how I'm doing y over x. It's important that we do y over x when looking at this. And for this one, 42 over 12. Okay. Let's go ahead and take a look here now to figure out if this is proportional. We have to look at the unit rates. Remember, to get a unit rate, we're getting our denominator to be 1. So let's make that denominator 1. And what do we have to do to get a denominator of 1? We're going to divide by 3. Divide the top by 3 here. And using old trusty Rusty, 10.5 divided by 3, we get 3.5. Okay? So the unit rate for this one data point is 3.5. If we find that all these other unit rates are also 3.5, then we can say that this table is in fact proportional. Let's take a look at our next one here. Again, we're getting our denominator to be 1. So we're going to divide by 6, divide the top by 6, and 21 divided by 6, we get 3.5. All right, guys, this is looking good so far. Okay, now just 2 data points is not enough to determine that this is proportional. What we need to show is that all 4 of these unit rates will be equivalent to 3.5. Let's move along here. Okay, we're going to get this denominator to be 1 by dividing by 9. Divide the top by 9. And 31.5 divided by 9, we find is 3.5. Oh, I'm getting excited now, guys. One more here. If we can show that this has the same unit rate as these, then we can determine that this is, in fact, a proportional relationship. So let's go ahead, go through the same process here, dividing both top and bottom by 12. That didn't look like a 12 very much, but it was, believe it or not. And 42 divided by 12, we get, oh yeah, 3.5. Great. Now that we've shown that all of our unit rates are the same, we can say, yes, this table represents a proportional relationship. I don't know what I'm doing here. I was running out of space. Running out of space. Proportional relationship. There we go. Because all of our unit rates are the same. All right, let's take a look at another one. Let's actually have you go ahead and try this one. Again, remember to set up your y over x. So let me actually get you started with this first one here. We're going to make this a 2 over 3. Okay, y over x. Do the same thing for all these. 4 over 6, 6 over 9, 8 over 12. Go ahead. All right, nicely done. Let's see how you fared. I'm just going to rewrite all of these as 4 over 6 and 6 over 9 and 8 over 12. There we go. And now all we're going to do is see if all of these are equivalent. Now, we don't have to go through the process of making the denominator 1. If we just do 2 divided by 3, whoops. Like that my eraser is hidden over here. There we go. I want yellow for that one. 2 divided by 3, that is 0.6 repeating. All right. 4 divided by 6, that is 0.6 repeating. All right. 6 divided by 9, that is 0.6 repeating. 8 divided by 12, that is 0.6 repeating. So is it proportional? Yes, it is proportional because all of our unit rates are the same. All of our unit rates are 0.6 repeating. They are all equivalent to 2/3. All right, here's another one here for you to try. Go ahead and determine if this table is proportional, remembering that we're looking for our ratio of y over x. Y over x. You might want to, some students like to make a separate column here, separate row, I guess. Y over x. All right, let's see what we get here. So let's start off with this first one. We have 7 over 1. Well, that one's already reduced. It's already as a unit rate. Let's take a look at this one. 8 over 2. 8 over 2, well, 8 divided by 2 is 4. And right there, look at that. Oh, no. Oh, no. These unit rates are not the same. They're not equal. So we can determine already, that is enough information for us to determine that this table is not proportional. Because the unit rates are not equal. Oh, no. Oh, man. Bummer, dude. Let's see what else we got here. Go ahead and check this table. All right, again, let's test this out. Again, always doing y over x, y over x. So I'm looking at 1 over 2. I'm looking at 3 over 6. I'm looking at 6 over 12. And I can tell already 1 divided by 2 is 0.5. 3 divided by 6 is 0.5. 6 divided by 12 is 0.5. It is a good day, guys. This is a proportional relationship. Yes, proportional. Because all of the unit rates are equal. They are all 0.5. It's a good day. Okay, now we've determined how we can find out if a table represents a proportional relationship. But how do we find the constant of proportionality? Well, guess what? Our constant of proportionality, which is represented by the letter K, is y over x. So if a table is proportional, your unit rates that you all found to be equal, that value is your constant of proportionality. Okay, so for example, this last table here that we looked at, all of the unit rates we found were equal to 1/2 or 0.5. So our constant of proportionality for this table, for this relationship, is 0.5. Okay, now we only have a constant of proportionality if the table is proportional, if we are talking about a proportional relationship. Let's go ahead and see what that's going to look like for you in IXL. Now, don't be too worried about all this wording. Most of it is just in case you're a little bored and you want to read a little bit. This just gives you some background information as far as what we're dealing with. But the main thing to gather here is that it's telling you right here, there is a proportional relationship between the amount. So it's telling you that this table is proportional. It tells you right here. Okay, you're not determining if it's proportional, but it tells you that this table shows a proportional relationship. So what is the constant of proportionality then? Well, remember, our constant of proportionality is equal to y over x. It is our unit rates that we found here, right? It is 5 over 1, 10 over 2, 15 over 3, 20 over 4. Now, we don't need to look for all of these. We already know it's a proportional relationship. We know all of these unit rates are going to be the same, and therefore, we know that our constant of proportionality is any of these. We could take any of these data points and put it in for y over x, and we find that it is 5 over 1, or 5 seconds per 1 ounce. Go ahead and see if you can find the constant of proportionality for this table. Again, you're not determining if it is proportional. It's telling you right here that it is a proportional relationship. There is a proportional relationship between time and Hanby spends, how much he spends. Go for it. All right, let's go ahead and find our constant of proportionality. Again, since we already know this is a proportional relationship, we can take any data point there and look at our y over x, and that will determine our constant of proportionality. So let's just take these smaller numbers. I like small numbers. So k is equal to 4 over 5. If you put 4 over 5 and write your answer as a whole number or decimal. They don't want it as a fraction. So let's go ahead and write this as a decimal, which would be 0.8. That's it, 0.8 swings per 1 day, right? That's our unit rate for each of these data points. It becomes our constant of proportionality since we are talking about a proportional relationship. All right, here's what you're doing then today. You've got 2 IXL skills. You've got K.1 and K.7. Both of those are out of 80. Okay, so 80 is 100%. Go ahead, work on those. Have fun, guys. Remember, we're doing math, so keep smiling. See you tomorrow.